ANOVA. It is not something difficult. It is something enjoyable. It is something uplifting, especially for those who like analysis. Fortunately, by virtue of being a PhD candidate, you are analyst. You like it or not. So you have to enjoy ANOVA. You have often wondered, how is hypothesis testing related to ANOVA? How? The other time we spoke elaborately about hypothesis testing and why the significance level has to be too low. The level of significance has to be too low, 0.05. It's important that you understand why we do ANOVA. There are calculations in ANOVA. And, in this class, how we do our calculations, we use software. One of our very favorite members said that they'd never used calculator in the last so many years. But there's a way in which we do our calculations. So ANOVA in full only means analysis of variance. What is variance? Once you hear something called variance, it means something varies. Varies from what? Varies from mean. So when you hear variance, that is amount of variation from mean of several observations being used, of all the observations being used. So ANOVA is analysis of variance or analysis of deviation from mean, population means. How is that helping us in research? Because once we understand how something helps us in research, then we embrace it. Now, when we are testing equality of population means, multiple regression procedures or experimental designs, we find this very, very useful. Let's start with population means. Yesterday, there was a wonderful presentation of a PhD candidate who is studying autism. And this candidate did extremely good work. The only gap that was there is the experimental design. The sample size of the population. So that if you have a smaller population, smaller, you have challenges with generalization because if your work is going to inform policy intervention, then generalization must be part of it. And you cannot make generalization with a small sample. You make generalization with a big sample. So let's talk about means. why are we so much concerned about mean when we're talking about ANOVA or experimental designs? Why? You know, it is easier for us to measure how things generally behave. If you are in nutrition and you know the weight of 9-year-olds, which should be between 20 and 25, then you have 1,000 of those 9-year-olds. Then you calculate their mean, you realize that maybe between 20 and 30, the mean is around 25. Now, if you find a 9-year-old that is weighing 36 kilograms, that's a serious deviation. So this is deviating from the mean by around 11, from 25 to 36. And that is not good. Then you want to think this is going into areas of obesity, overweight, what interventions should be given. So mean is important to us because it helps us to measure deviation from normalcy. That is the importance of mean. It helps us to measure deviation from normalcy. Now, let's talk about experimental designs as far as ANOVA is concerned. Let's bring into focus school feeding program. For instance, this could be a research project to somebody. For instance, there are certain schools, public schools in Nairobi, that are offering feeding program where pupils take food, that is lunch, in school. And there are schools in other counties, or maybe the same Nairobi, where pupils the schools do not have feeding program. So you want to measure certain things about these two groups. There's a group of schools that are on feeding program for pupils. There's another group of schools that do not have feeding program for pupils. In ANOVA, the group that has feeding program, that feeding program, we call it intervention. We call it treatment. That feed program in ANOVA, we call it treatment. So the schools that have feeding are called the treatment group. The schools that have feeding program. And if you are making a kind of experiment, studying them, you need a large number, a good number of them. Then the schools that are not having feeding program are called the control group. So we have the experimental group and the control group. Now, presented with such a scenario, you can measure so many things as a PhD candidate. One, you can measure if...
Mwalimu?
Yes, please.
Is the treatment group the same as experimental group?
Yes, yes, yes. That's true. That's true. Very true. Thank you. Yes, that is the experimental group, is also the treatment group. Now, you can measure two things. One, malnutrition. You can measure, maybe your hypothesis is that feeding program in public primary schools reduce malnutrition among children aged below 13. The specificity of hypothesis makes it easier to test it. So say the feeding program in schools, feeding programs in primary schools in Nairobi reduce malnutrition among children aged 13 years and below. That is null hypothesis. Then the alternative hypothesis would read, feeding program for schools in Nairobi, and feeding programs for primary school, public schools in Nairobi does not reduce malnutrition for learners aged 13 years and below. The only difference between the null and the alternative hypothesis is the presence of the word not. One is not. It is the alternative hypothesis, the direct opposite of the null hypothesis. So now, that is one of the things you can choose to measure. That is, if you are in clinical sciences, you'd want to measure if feeding program in schools actually reduce malnutrition. And you see the impact of malnutrition at things like stunted growth, underweight, and associated ailments like kwashiorkor and the rest. Then that is one aspect you'd want to study. The other one would be if feeding program in school actually improve performance of learners in the experimental schools, in the schools that feed the learners. So your null hypothesis will be feeding programs in schools, in Nairobi schools, improve performance in national examination, improve learners' performance in national examination. Then the alternative would be feeding program in schools in Nairobi does not improve performance of learners in national examination. So you are set to test these two scenarios. One is mostly oriented towards those people who are either in development, that's performance, or in education. They want to see development or education. The other part of malnutrition for those people in health and health sciences, you'd want to know. So you see, by just feeding program, you can collect data that supports two or more kind of studies. Maybe this feeding program was just started to improve performance the children or the learners, when they travel from school to home, they delay in returning. Some of them don't find food at home, they come. So it was maybe started to improve performance. But you who is interested in health want to know how, whether it reduces malnutrition. So this data which was being collected to support performance, you are now going to use it to study malnutrition when it was actually meant for that. That's what we call data mining. You mine a section, use a section of data to serve your research interest. That is what we call data mining. Now, when you collect all data, for instance, on performance, you wait for maybe it was started, the feeding was started when learners in that school entered grade 6. And they will do their exams, let's say, in grade 9. So you are following them, grade 6, grade 7, grade 8, then grade 9, they do exams. That fits into what we call cohort study, because there's this cohort of those learners in grade 6, and you are following them for 4 years, and every time you record their performance, end term performance, and you'll finally record their performance at grade 9. That is called a cohort prospective study. Prospective study means you are providing the intervention. You look at the intervention going forward. Then if it is a retrospective study, which means something that had already happened, maybe Nairobi's county government started feeding learners 4 years ago, and you're studying the results today, their exam results today. That is retrospective, because the intervention, the experiment already happened, and now you want to see whether that intervention made a difference. So in research, mostly I see people going for retrospective study because, one, it is less costly. It is cheap. You only have to have some data agreement on confidentiality, on acceptance, and after getting your approval from NACOSTI, your protocol has been approved by Dista University. Ethical review, they can access the data, you seek consent, then you are good to go. They give you data, you analyze. That's why most people prefer retrospective studies, because that happened. But prospective studies are very costly, they're time consuming, they're very exhausting. I see most researchers try to avoid them, except in medicine. In pharmacy, in medicine, they just have to do prospective studies. especially when a new drug is being introduced into the market. Okay, back to our feeding program, where we are doing the prospective aspect of it, is this. For performance, in this grade 6, there are around 600, or let's say 3,000 students whose you're following their performance. 1,500 are on the control group. 1,500 are in the experimental or treatment group. Then, because you have their scores from grade 6 to grade 9, you find the average of each learner and enter, because you have to be very fair with them, for all the grades. That is if you want to do the general performance. But if you're only concerned with the national exam, maybe KPSEA, you are concerned, you only enter their final marks at the end of that national exam. Now, after you have entered them for the experimental group and for the control group, your concern here is whether these performances are different, statistically different, or there's no statistical difference, which means the intervention does not improve performance of learners. That feeding program does not improve the performance of learners, which would mean you reject the null hypothesis. Or there's actually significant difference in the performance, which means you fail to reject the null hypothesis. And you do that by using the mean performance of the learners in experimental group and the mean performance of learners in the control group. Are those means statistically different, or there's no statistical difference at all? Now, that is where you use ANOVA to tell you whether the means are different or not different. Then you write your report that the feeding program in Nairobi actually improves performance of learners. Then in your analysis, you will discuss, especially, there's one part here that students are struggling with. When you're writing your discussion, you are a thinker once you're here. You give reasons as to why you think this difference is there. Why the performance of learners in the experimental group is higher than the performance of those in the control group or non-experimental group. You'd reason the time, because they have to try, while the experimental group eat in school, the other ones have to travel home and come for lunch and come back. That's one. So there's the element of time. The time is judiciously used in schools that are offering meal programs. Now, the other one would be in the control group, there are learners who go home and realize there's no food, or the house help or the home manager, if you use a better word, did not make food in time. They're late or they got no food, then they came back. Some of them, the delay, because where they're going, they have to use a vehicle, public means, it's traffic. A very insignificant proportion might be involved in an accident, things like that. So you write and explain in a very scholastic manner. You don't write like somebody who is citing poetry, write in a very scholastic way. Now, that is not complete. Remember in your literature review, you had cited some people, some papers that said, that supported your Nile hypothesis, and you also included the papers that refuted your Nile hypothesis. Now, when you're writing discussion, you again revisit and say that the results agree with so and so, et al., who said this, and that. Or these results disagree with Shem et al., who said that the feeding program improves. So in that way, your discussion is comprehensive, so that if this work is going into policy, it is thorough. There are people in that policy group who have read certain papers and they think those are the papers refuting what you found out are what is important. Then your empirical findings have also support and evidence of the validity of your results. That is why we do literature review, and that is how we write the discussion of a paper. And it is important that when you're doing literature review, I'm sorry, this is not the forum for literature review. When you're doing literature review, consider two opinions. One, there's a set of scholars whose works refute what you're trying to say. They're very important. Then there's a group that actually support what you're trying to research, to what your Nile hypothesis says. They're equally important. Don't just go and those that support you are the ones that you include. No. That's not comprehensive enough. Just ensure you have those that. That's why there's democracy. In literature review, then there is democracy in politics. You must consider all views, those that support your argument and those that do not, so that when you finally analyze your results, you have something very interesting to say about the people who, the works that did not support your argument, your null hypothesis, and the works that supported your null hypothesis. And you could have also discovered in the process something new. For instance, if in your data about the feeding program in those schools, you are on the clinical side and you realize that the feeding program actually reduces malnutrition.
Good.
Then in the absenteeism, in one of the reasons why you realize that there was absenteeism in schools that were not from the control group. And then you realize if you do key informant interviews, even before you do key informant interviews, there are reasons for absenteeism. Realize that large number of learners who were absent because they were sick. And maybe they were sick because of, hypothetically, maybe running stomach, or they say do something like that. Then you will realize that, then if feeding in school reduces the chances of having sanitation-related diseases, because the food is well prepared and preserved and served in school compared to home. That would be some knowledge you have improved, you have discovered in your work when you're doing. Or you realize that those who eat in school, some of them, their level of absenteeism is very frequent. Their frequency of absenteeism is high. Then you get to know why. You realize some of them had sanitation-related diseases, ailments like cholera, dysentery, loose stools, running stomach. Then what you've discovered here would inform policy in hygiene in schools that are running feeding programs. That's something new you shall have discovered. Or you realize that malaria is low among those who feed in school compared to those who go for lunch at home. Then you want to find why. You see, in your analysis, that is how we extend the boundaries of knowledge in research, little by little. But these are only possible with ANOVA. I wanted you to understand the importance of ANOVA in your research. So whether you are doing retrospective or prospective studies involving cohorts, populations, groups, you will find ANOVA very, very useful. Please, Annette, go ahead.
Thank you, Prof. I wanted to ask a question that is related to what you're mentioning. In such kind of a study like the school meals program, or perhaps scholarship programs, and you are taking the prospective approach or the prospective study, how do you ensure that the ethical issues do not deny other students or beneficiaries an opportunity to benefit from the intervention? Like especially when you're identifying or you're sampling the control group. For instance, you're doing a case study of a public primary school, and all children are equally in need, and you are taking the prospective study, and you have a number that is representative of the control and another one the treatment group. How do you ensure that they also benefit because they are also equally in need, and the ethical issues like are not incriminating you in the study, and at the same time you want to find results?
That's a wonderful research and practical question. Let me ask you, Then I will respond thereafter. When we introducing a new drug into the market, then we first administer this preclinical trial in rats to see how this intervention affect them, side effect, immunogenicity, reactogenicity. That is how they react to this. How does this help rats? How does this help rats? We are using them in experiment. How does it help them? Well, it doesn't help them, but it helps ourselves. So, I am answering your question. When we are having a prospective study where let's use the case of feeding program, where we have the feeding program as an experiment, as a treatment in one set of group, and the other group, the control, we're not giving them anything, we're just studying them. Ethically, we are not interfering with their conditions. Their status remain the same. But we are interfering with the experimental group. That is if we are the people offering them that food. But if the other school, it is the government or county government of Nairobi offering that food, it is the county government improving their status. As for us in experiment, what we are doing is to study how this intervention impacts, one, their nutrition and their performance, academic performance. This is not going to disadvantage them, the control group, in the long run, because maybe this is a pilot program of feeding in school. Before the government now decides that all schools in Kenya are going to have a feeding program, just like those of us who drank maziwa ya Nyayo. So you've just taken a small section of the population to study the impact of this intervention in the learners. After which, depending on the outcome of the experiment, they will be rolled out the entire country. It has benefited them in rolling this out. When this is being rolled, it has helped them in policy. It has helped so many people in policy going forward. And the control group are not harmed by our intervention at all. That is why before you are allowed to do research that is on human beings, you have to go for ethical approval from Daystar University, Isaac, or in, like now, Kenyatta National Hospital, Isaac, MTRH, Moi Teaching Referral Hospital, Isaac, or Jaramogi Oginga Odinga Teaching Referral Hospital in Kisumu, Isaac, where I sit. So, when in your protocol, in fact, the protocol is just your proposal on how this intervention is going to be conducted. When your protocol is in any way deemed to negatively impact the experimental units or elements, it is not approved. So an intervention that interferes with the status of the experimental units, like vaccination, like injection of the drugs into the bodies, intravenous treatments, those must have the framework of one, that they will not have alter the state of health of the study units. If they do so, there's compensation that must be given to them, those that are damaged in one way or another. They must have that. In development, there is devolution in Germany, Indonesia, and other countries. Now, I was reading the devolution in Germany the other day. There are certain interventions that people are not sure of in terms of impact in the long run and in the short run. They can be implemented in one county. If they are found to be working and have more benefits, then they are upscaled to other administrative units everywhere in Kenya, all counties in Kenya. So devolution gives government in Germany to try something in a smaller section. If it works, it's rolled out in the whole country. If we were good enough, devolution, the feeding program would actually, if we find it to be working in Nairobi, then we roll it out in the entire country. So that would be a big policy benefit and actual benefit in it. Studies had shown, those people who did studies when we were naive, we were in primary school, have shown that maziwa ya Nyayo, the Moi milk program, actually reduced malnutrition among primary school going children in that time. What I haven't read there is whether it was first tried in Baringo for a short while and found to be working, then rolled out to the entire country. So we are going to see how it works. So when we're doing, we have discussed much about these slides, but in everything that the population experimental groups must be must have normal distribution. The variance of the response variable is the same for all populations. We have to ensure the population must be independent. The observations must be independent. All the observations made are independent. Whenever we are dealing with analysis of variance, and now we are going to say this, the quantitative way of null hypothesis is that the mean of all population, all groups being tested are the same. The mean treatment is just the same. Mean of everything, of that observation are the same. We're saying that the mean performance of schools that are in feeding program and those that are not the control group is the same. The mean performance is the same. Then the H1, the alternative hypothesis is that they are not. I know this is the part we don't like most, but you have to be shown how this calculation is done. But don't be worried. We are going to do this using the software. We are going to do it using the software. So if you, for example, let's say that you are in agriculture or manufacturing any kind of thing, then plant one is able to manufacture maybe 85 tons of whatever it is. Maybe these are manufacturing, fertilizer manufacturing bags, maybe per day. Then the other one, plant 2, all that, up to plant 3. Then you look at their mean. Plant 1 mean is 79, the mean of all the bags made. And then plant 2, 74, and the other one is 66. If you look at their variance, is as shown. Then the standard deviation, which is the square root of variance, is as shown. Now, when you use this to calculate ANOVA, it is about comparing the means, the overall mean. Don't be worried. You have to be shown this. At least you already know why we are doing ANOVA. These are nothing to do with it, but just about the mean and variance. Then until you do the formula, I want to rush you to the software and show you what all this means and how we are going to calculate them. A word like mean square due to treatment is when we measure all the variations in treatment, which we call the squares, then we find their mean, that is called mean square due to treatment. We also have mean square due to error. Now, when you reach, this is where we use the F test. If after all the calculations, the mean square due to error and the mean square due to treatment, you divide the mean square due to treatment with the mean square due to error, you find your value. That value is F, is run on the F table. I want to take you through this, then we go directly to R to run something. Now, if in the F table, the value you have computed is greater than the critical value in the F table, then we say that the means are not the same, are statistically different from each other, and we fail to reject the null hypothesis. But if the calculated one is less than the one that is not than the critical one, we reject the null hypothesis. So these values you see here, this is how an ANOVA table looks like. If you look at degrees of freedom, the treatment groups are 3, but it is always K minus 1. So K groups, K minus 1 is 2. Then these are 15, they're supposed to be 18. So it is N minus K. K are 3 groups, so out of 15, 17. So the total degrees of freedom is here. Now, I want to, if you divide 258 mean square of treatment by mean square of error 28.67, your F value will be 9. This F value, if you check it in the table, F table, you realize it is higher than the F critical, which is 3.6. In this case, we fail to reject the null hypothesis. So don't worry about this calculation. Just open your R console and see how this thing is easily done. And today, we'd want a volunteer because we are going to use your R console to take the class through this calculation. Do you still need the few minutes breather? 5 minutes? Or we proceed?
We can proceed. We can proceed. Thank you.
This is good. So whose console are we going to use? Charity. Thank you. Share your screen. Share your R console.
Maybe you give me a bit of time.
Okay.
Yeah, because I was using 2 computers. Let me log in to the class with the other computer, if you can.
Okay, that's fine.
Okay.
That's fine. So, ladies and gentlemen, you realize that ANOVA is what you have been missing in your research. For example, in the case of Millie, if you have groups, you can have 2 groups. Well, if there are constituencies where members of parliament do not sit in the board, I mean in the CDF committee, that would be your experimental group, and where they sit is the control group, because that is what's happening normally. And then you find if the administration of that devolved fund is effective, then you can use the ANOVA to analyze and give your findings. I will volunteer for at least 2 members of this class that I become the other supervisor to ensure that you can do this. The good thing is that your results, your paper will be so valued, and it will inform policy because it has the rigor of science inside it. So whatever you do, find how you're going to collect that data. Okay, Dr. Livingston.
Can I volunteer? I think I'm ready.
You ready?
Yeah.
Okay, I'm seeing Victoria.
Yeah, mine is a question.
Yes.
And my question is, for example, if you are not using is it experimental?
Yes.
A study, it's if you are using, because like for me, I'll be using quantitative, but maybe regression or correlation, no? In this case, do we have to have a control group? I'm thinking no. Or what would your advice be? And in such a case, then would we still use ANOVA or, yeah, just that. Thank you.
Yes, you can use in the if you have two groups that you want to compare, two or more groups that you want to compare, you can use ANOVA.
All right.
But if you have just variables that are not grouped, they not have uniform treatment of things, there's no uniformity, then you can use the correlation, and you can also use the regression, okay? And use that. So we have two people who have volunteered to share. Let's start with Dr. Livingston. Dr. Livingston is somebody who claimed to have discovered Lake Victoria while people were living there.
The people who are living there didn't calculate turnover.
Okay. That's good. That's good. Now, there is this data that I shared in class that is called cases, okay? Do you have it?
Mwalimu, I'm ready, but I'm not allowed to share. The host has disabled the sharing on my screen.
Okay, I think now you can share. I see the person who discovered Lake Victoria while we are living here has pulled out.
The old adage says ladies first.
Okay. And everybody else must open their own R console.
Mwalimu, it's still disabled.
Let me see. But how come Livingston was able to share?
Livingston and Rachel were made co-hosts.
Oh.
Yeah.
I think it's okay. They can share then. Yeah, because I'm not able to share on my side.
Mm-hmm. Livingston, are you able to make Charity co-host?
Let me try that. Yeah, I can. Charity, let me
please. Go ahead.
Yeah, I don't have the rights. The host has the rights to do that.
Yeah, Prof, I think you're the one who can make Charity co-host because you're the host.
Let me see. Let me see. Make host, yes. Okay, now try. You see, in most of these clinical trials of drugs, they actually use ANOVA to see if the treatment is effective.
Mwalimu, it's still not working.
Okay. Now, it's okay. Livingston,
Yeah,
you're
I
not
can
going to
share.
escape this.
Yeah, I can now share. I can also discover over here.
Yes, yes, yes. You can really discover it. Okay.
Okay. Let me share that.
Okay. Now, the data that we had on cases, are you able to find it? You do know how to import it?
You can remind me, but yes, I do have it.
Okay, then write cases, small letters, cases, small letters, yes. Assignment operator, cases, put assignment operator. That is this symbol less than, and then that is greater than. Yes. Then a dash. Then read.csv. Open bracket. File, write file. Dot choose. Open, no, open a bracket, open another one. Close that one again, close that bracket. Now close another bracket, enter. Choose where it is. Did you put it on the desktop or the?
Yeah, the desktop.
Okay, that's your desktop. I think it should be this other one on the top left. Oh, you've selected it.
Yes, yes.
Now call it, just write, no. Go write cases and enter. Enter. Good, yeah. Thank you. Now, I have to explain this data while we are, for us to understand it. During COVID-19, different regions were affected, infected differently by COVID-19. The regions are classified according to WHO, World Health Organization classification. We have the African region here represented by Afro. These countries are selected in no particular order, except Tanzania. Tanzania was not represented here because they were not reporting data. Magufuli said they did not believe COVID was real, so they were not reporting any data. Oceania are these countries that I call Oceania. They are the West and East Mediterranean countries. This is where we have the most countries in the Middle East, some countries in the Pacific, East and West Mediterranean. Then America, are the Americas. No, every time we talk about Americas, some people think it is only the United States. No, this range from Canada United States, Mexico, Argentina, Brazil, Peru, Chile, all the way, Cuba, all the way down there, the Americas, sorry, the Americas. So, including Paraguay and Uruguay. So their infection, the number of people had infected by 9th of May 2020, I listed there. Then Europe, the countries like France, UK, Germany, Luxembourg, all of them, there are 22 of them chosen in no particular order, except that the reported cases were put here. So what happened is that we wanted to check the level of if the mean infection are the same. If you have this data on your desktop which you're using, try to run it or find summary of it. Just try to find summary and see the results. Just summarize that. Has anybody found summary? No, I did not say you'd summarize in Excel.
Okay.
No. Just go to your R.
Okay.
Just share your R console. Okay. Just write summary in small letters. Summary. Open bracket. No. Scroll up. One more. Yes. Summary. That's not the spelling of summary. Double M. Open bracket. Cases. Close bracket. Enter. So here you see you have the mean, median, first quartile, maximum, minimum. That is just descriptive statistics. And you see that the mean infection in you can see the mean infection in all those regions. The other thing now you can do, we want to after comparing, after looking at the means, now we want to now we want to start running the ANOVA. But when you're running ANOVA, you must install some packages here in R. So Dr. Livingstone, go to packages on top there. There's file packages, yes, they are good. Then set CRAN mirror. Yes, select it. That is comprehensive R archive networks. Set CRAN mirror. Choose any country at random here whose mirror we want to use. I see you've chosen Canada. It's okay. Good. So you cannot use any other unless you do that. Failed. Can you choose another one? Go back to packages. Crown mirror. Choose
Which
China.
one have you not discovered?
Can you please discover China? China is there.
Okay. China.
Any China. Yeah.
China Beijing. Okay.
Let's see. Phil, try Chile. Chile is just after Canada. Yes.
Mwalimu, could you please remind me why we choose these Grand Mirror countries?
Many scientists are working on R. And they have the rights on whether you want to use their domain. In Africa, the only country that has a mirror is South Africa. So let us try South Africa. We are all Africans, so let's try South Africa. Just good. Yeah, I'm seeing South Africa there, Johannesburg. Yes.
Yeah.
And enter. Why is yours giving warning?
Even mine is giving warning for South Africa.
I think you have firewall that does not enable us to. I think you have a firewall.
Okay.
Yeah. So, Victoria, are you able to share? Dr. Livingston.
I can stop sharing.
Yes. Then we check the.
We try.
I think mine has accepted China.
Who has accepted China?
Mine has accepted China.
Okay. Who? Victoria, are you able to share?
Host has disabled participant sharing.
I have to give you the rights. I have to.
Maybe Charity, you can return the host right to Prof.
Rachel, I was not given the rights.
You are host, so make
I'm a host.
Shem, yes, make Prof Shem back as host.
You just go to the three dots.
It's saying pin, just pin. That's what it says, Rachel. I click on the three dots, it's just saying pin.
So, Dr. Livingston, try to make somebody.
Yes, Prof.
Yes. Try to make Victoria the host.
I'm a co-host. Ordinarily,
Yes.
you can do that when you are the host. Maybe you make me the host, then I do it.
Am I still the host?
No,
No, you're not.
Yeah, I'm
Charity
not.
is the host.
Charity, you are the host.
Oh my God, it's just saying, okay, it has said remove pin. Let me remove it.
Yes, share on
And
screen.
now,
We can.
are you okay now?
Now go into my name and press the 3 dots and choose make host.
The 3 dots are just saying remove pin or pin.
Charity, I think you are logged in two devices, eh? So it's the one of the devices she's showing host, the other one is not showing anything. So please just check the other device because it's the one that is showing host. Or maybe you can just use one device to log in.
Okay.
Oh.